All right, Cedar Crest Chargers. Today we're working on example 3 and 8.3. It's talking about finding maximum and minimum values. Okay, and so here's a little schematic of maximum and minimum. And this has everything to do with whether A is positive or whether A is negative. So as you can see, I have two quadratic equations, and you'll notice that the A on the left is negative and the A on the right is positive. And so we're going to go through how you figure out if it's a maximum value or it's a minimum value. The y-coordinate of the vertex of the graph is the maximum of the function where A is smaller than 0, or the minimum value of the function when A is larger than 0. So it has everything to do. So you need to be able to figure out whether it's a maximum or a minimum, the vertex itself, or that value for the vertex. And that's also going to help you, calculate domain and range, right? Or at least the range portion of it. So let's go ahead and get to it. And so the first thing we've got to do is find the x-coordinate of the vertex. And again, we'll go to red. We're going to use this particular formula, right? The x equals the opposite of whatever b is. So b is negative 24. So negative 24 over 2 times a, and a happens to be negative 4. So on this one, the x-coordinate is, this becomes positive 24. This becomes 8. So the x-coordinate is negative 3 on this one. All right, and so then after we find the x-coordinate, then what we're going to do is we're going to substitute that back in everywhere we see x, and we're going to figure out what our output is. So that's negative 3 to the second power minus 24 times negative 3 minus 19. So in this one, that's 9. Negative 4 times 9 is negative 36. And then we have 3 times negative 24. Let's see, 72, positive 72, right? And then negative 19. So we've got negative 36 and 19. What does that make? Negative 55. So we have 72 and negative 55. All right, and so borrow from the 7, make that a 6, 12, that's 7, 17. Okay, so on this one, it's at 317, right? Okay, so that's where the vertex is, and then here is the y-intercept, or the c, right? So where would 317 be? It would be to the left and up 17. Let's just pretend this is 17, and this is negative 3. And then from there, it crosses the y-axis way down at negative 19, So this parabola is going down like that, right? So the question is, what is that? Is that a minimum or a maximum? Okay, that is a maximum, right? That vertex is a maximum, right? Maximum. So here's kind of the way to think of it. When A is negative, that vertex is going to be a maximum. Okay? When A is negative, that vertex is going to be a maximum. Okay? When A is positive, the opposite. It's going to be a minimum. Well, let's just see how that works out. Okay? We'll do that in blue. All right. So let's see. We have the opposite of B, so that's negative 24 divided by twice A. So that's what, 2 times 4. All right, so we have 24 over 8, which is 3. Okay, so our x value is positive 3. We probably kind of expected that. And then we need to plug that 3 back in to figure out what our output will be. So that's 4 times 3 squared, right? Minus 24 times 3 minus 19. Okay, so, yeah, what are we going to get here? 9, that's 36, minus, what was 3 times 24? 60, 72, minus 19. Okay, so we have 36, we have, so 72 and 19, what is that? 82, 91. So 36 minus 91. It's kind of like 91 minus 36. Let's figure that out. 8, and that's 11, so that's 5, and that's 8. Negative 3 is 5. So this is a negative 55. Okay? So this vertex is at a positive 3 way down at negative 55. Let's say this is a positive 3. That's where that vertex is, and the y-intercept is at negative 19. Okay, so there's negative 55, there's negative 19, and so that's going up like that. So that is a minimum value, okay? And what that means is that that vertex, that is the lowest output of the parabola. So that particular spot is the minimum value that this can be. So hopefully we understand, I'm hoping, that the difference is whether the A is positive or negative. A negative A will give you a maximum. That vertex will be a maximum value, which means that the parabola will be going down. Every output will be getting less and less and less and less, and then vice versa. When A is positive, then the vertex is the absolute lowest vertically or output-wise, and every output is higher and higher and higher. I hope that helps, Chargers.